Now let's have a quick look at the different UI elements of WinDebug, and we will see how to use WinDebug for general debugging and stuff like that. Nothing in depth, it is more of showing what is where. So what we have here is a simple Hello World application which is developed in Visual Studio. WinDebug can debug pretty much any programming language as long as it is running in Windows. But to see the stack correctly, see the symbols correctly, we need a C or C++ application. If it is a .NET application or any other programming language, we need an extension for that particular programming language which understands the runtime. So we will see the symbols and relation to it pretty soon. In short, if you have symbols for a particular programming language, you can debug that program inside the debugger, WinDebug. Now, for all convenience, I have a simple C program or C++ program here. And what I'm going to do is I'm going to build the program and I'm going to debug it. Right now, I'm going with the 32-bit version. So this is the 32-bit version of the Hello World application. I'm using Visual Studio 2019, which is the latest version of Visual Studio right now. But by the time you see this video, there could be later versions and you can use it. And this is a community version of the Visual Studio. You want to have a look. I'm not going into the details of how to create this application in Visual Studio, which is kind of outside the scope of this particular training. So if you're curious how to do this demo by yourself, you can install Visual Studio 2019 or any of the later versions or all the versions, and then select C++ inside the Visual Studio installation so that you will get the C++ runtime, and you can just double click the solution file which is associated with this training. So I'll be providing all the files, required files along with this training. So that is how you can reach this particular point which you are seeing in the screen right now. So if you are new to C programming, it is just a Hello World C program with just a main, and it is printing Hello World right here from a variable. This is a print statement. After the print statement, I have something called a breakpoint instruction. So this is a breakpoint instruction which I will be explaining shortly. Nothing but it is an interrupt. It is an interrupt 3. It is an instruction to break into the debugger. This program will by itself break into the debugger. That's what this int 3 is about. Why do I have this? Because I have planned to debug. I am artificially creating a problem in this particular application. I just wanted to stop the execution of this particular application at this particular point where I have highlighted. Artificially, I am creating a problem so that it will try to stop the program and it will start the debugging. Let's see what happens if I execute this program. Right now, if I press this button, it will use the debugger which is associated with the Visual Studio. So let's see that. There is no harm in trying that. So I have executed the application. This is how the Visual Studio debugger looks. It is clearly saying Hello World exe has triggered a breakpoint and it has broken here. The program stopped here executing. If you look, it has printed Hello World here. So this is a program window, what you're seeing here. And it has done the printing. So it has executed this particular statement. It was successfully executed. And then it encountered the problem. This is a problem line. It is causing an exception or interrupt. It broken into the debugger. We will see how all these things works in detail through the presentation. I just wanted to show you how this ASM int3 behaves because it could be new to some people. Now what I'm going to do is I'm going to start this program in WinDebug and we're going to see how it looks in WinDebug. We have seen how it looks in Visual Studio. Now let's see how it looks in WinDebug. So I'm going to right click here, open folder in File Explorer. So this is where the program. If I go to the debug folder, this is my Hello World executable. So this is the program which is generated after building it. Now if I double click on this particular program, it will crash because there is no debugger attached. It will crash and the dump will get generated using the Windows error reporting. We will see that later. That's not our focus right now. What we're gonna do is we're gonna open this program in WinDebug. We have the WinDebug started here. So this is a 32-bit application. I'm starting a 32-bit WinDebug. I'm going to file open executable. We will see all the other options, most of these options throughout this course. Right now, we are going with open executable. Then we are going to select the executable we just created. This is the executable we were talking about, and I'm just opening it. This breakpoint is not really the breakpoint we want. This is a breakpoint which is given by the WinDebug. We will talk about that as well. This is broken right now way before the main of the application. So main is the first function which get executed. This is right now way before that, this break into the debugger. How do I know? Because this is the application which has started, but it has no hello world in it. If the main was there, the hello world would have printed. I'm going to press G, the command G. So this is a command. I'll show you that as well. This is where you type the command. Instead of typing the command right away, I'll press the buttons. There are different buttons here. If you're familiar with Visual Studio, it's exactly like Visual Studio. This is the go, which is the G command. This is a restart. This is stop debugging. This is break. We'll see this 4 buttons, how those buttons are used. Now, what I want is go. Go means that now the program is stuck. The program is frozen inside the debugger. It is not able to execute any instruction. The program is completely frozen. It is completely suspended. If I press go, what will happen is it'll start executing rest of the program. Right now, there is a breakpoint and I'm going from there. I'm going to press go. Right now, I have hit the breakpoint which I was given right here. The breakpoint we have hit in the Visual Studio. That is the breakpoint just happened. So now let's see what is a breakpoint. Breakpoint is an instruction or a point in program where the debugger stop executing the program. Right now, the program is not executing. It has broken into the debugger. If I look at the call stack, the command is K. It is right inside the main. I'll give you more inputs on what all these things are. But because of the breakpoint, the program has broken into the debugger. Now the debugger has complete control on this program, including the access to the memory to the program, so on and so forth. Debugger has every access to every bit of memory this program is having right now. Now, before going into too much detail, let's have a look at different windows we are seeing right here. So this window right here is the command window where we type command. This is where we're going to type the commands. This is the single most important window, and 99% of the course, rest of the course, we will be using only this window. Now, this is a source window. When you debug with WinDebug, 99% of the cases, unless you are a Microsoft employee or something like that, you may not be able to see this. This is coming right now because I have developed this code in the exact same computer and my symbols are set correctly. We will see what symbols are and stuff like that. Bear with me. And this is the command window and this is the source window where we see the corresponding source code. All the windows can be launched from the top of the screen. So there are a small menu there. You can launch. You can look at the disassembly window. So this is the disassembly of this exact same program. You can see the assembly instruction, which this particular source code is corresponding to. This is the disassembly window. All this can be done through commands. We will be using commands. Probably this is the last time we will be using the window way of doing it. Then there is a scratch pad. This is just like Notepad. If you want to put some information here, you can do that. Probably we'll be using scratchpad every now and then. You can turn off the source mode on and off, so source code won't come. This is the call stack window. This is where you look at the call stack. Unlike Visual Studio, we will have a lot of other parameters and arguments. You can see some of this thing you need to view with a pinch of salt, because in certain debugging scenarios, these variables and this argument doesn't mean anything. We will see that, especially when we discuss 64-bit debugging and stuff like that. Basically, there are more information than typical Visual Studio debugger or any other debugger. So again, there are commands equal to this window. That was the call stack window. So this is the watch window. If you have used normal debuggers like Visual Studio or Eclipse or anything like that, you will know what is a watch window. Watch window is where you see the variables, different variables, global as well as local variables. This is the watch window. Right now, I have not put anything in the watch window. That's why we don't have anything here. This is where we see the local variables. We have 3 local variables, which is 2 command line arguments. Then 1 local variable here, which is pointing to the hello world. This is where you see the local variable. This is where you see the registers, the CPU registers. All the registers can be seen here. Everything can be accessed from here as well. View, then selecting the window which we need. This is the memory window. We can see the raw memory. Everything we are seeing here, we can access through commands. For example, register, the command is R. For local, it is DV. For watch, you can type DT or again DV, depends on the scenario. Memory, DC, DXX, call stack K. For disassembly, the U command or U star. Process and threads, again, lots of commands are there. All these things we are seeing in the UI, we will be accessing through commands from now onwards. So how to put a breakpoint? This is a breakpoint F9. For example, if I want to put a breakpoint right here, I'm going to press F9 here. I put a breakpoint here. And if I restart, let me restart it and then show you how to put a breakpoint. I have restarted the application. It is broken before the main. I can open the source code. I'm going to open the source file path. I have opened this file here and I'm going to put a breakpoint here. So what I did was I just clicked on the line with my cursor and I pressed the key F9, or you can press this button, this hand-like button here to put a breakpoint. Now if I go again, F5, go again. So I'm going to press this button. So it'll hit the breakpoint. As you can see, the color has changed. It became magenta from red and it has hit the breakpoint. So that is breakpoint, which is inserted by the debugger. And there again, we have commands to put the breakpoint. So we won't be using these buttons anymore. We have the command BP, BM, so on and so forth to do breakpoint more accurately at different places. We'll see those. Once you have done with your debugging, it is Qt detach. QD is the command to Qt detach. Also, you can stop debugging, Shift F5 will stop the debugging and let the program go. Whatever is the fate of the program, it will happen. Right now I have clicked the Control F5. The program crashed because the exit code is -1. Program crashed and it would have created a dump in the Windows error reporting. I let the program go with an exception. So that is the overview of the UI of WinDebug. We will see more details, especially on the command window in the coming sessions. Feel free to explore this UI. It has a change of font and all those things. And whatever changes you are making here, you can save it using the workspace. You save the workspace, all these fonts and stuff like that. So this is not a font which default it comes with. I have changed the font to a little better. So all those cosmetic things you can do. Feel free to explore the UI. Let's get back to the slides. So we have seen this demo. We have looked at different UIs of WinDebug after installing it. And we have also discussed that most of the cases, we won't be using the UI version of the debugging, but we will be just sticking with the command window. Probably we will be using the scratch pad every now and then. Otherwise, it's just the command window we will be using. Types of debugger, kernel and user. Those are the 2 different types of debugging scenarios or debuggers we will be discussing here. User mode is debugging normal application, just like the one we have seen. Normal application which runs in the user mode, unprivileged application like Word, Excel, PowerPoint, Notepad, so on and so forth. Now the kernel debugging is the debugging of the driver or the operating system itself. It's more interesting. We will see that a lot in this series as well. Kernel dump analysis, kernel debugging, it's all the same thing. We will see that. So there are different debugging scenarios. Live debugging is the one which we have seen. A program is running and we attach a debugger to a live application. In our case, we have started a program from the debugger. We can attach as well. Those are the two live debugging scenarios. Also, you can attach to a live kernel. It'll be live kernel debugging. Then a dump analysis. So which will be a lot more focus will be on the dump analysis. And then we can open binary inside the debugger. Binary also pretty much behaves like a dump. A dump is also a photo of or instance of a running program. An instance which really matters. Normally that is what a dump is all about. We'll see throughout this course. Using the WinDebug preview, we will be seeing the time traveler tracing as well. Like I was mentioning, there are two types of live debugging. One is starting with the debugger and attach the debugger while the application is running. Once you start debugging, most of these things are exactly same. When you start using the command, it's exactly same. All you have when the application is broken into the debugger, all you have is a state of that particular instance, and you will be working on that.